So with shock, I've pointed out kind of like the hallmarks of each type. So we have the pump failing is cardiogenic shock, and I wouldn't take pictures till the end because I'm going to add a lot more to this stuff. But you have cardiogenic shock where your cardiac index is less than 2.5. You've got an elevation in CVP, an elevation in PAWP. You have a decrease in ejection fraction. With your prime, if there's something wrong with your prime in terms of shock, hypovolemic or hemorrhagic, this is the type of shock we generally think of, like where someone's losing a lot of blood. Sorry, that's my alarm to start asking questions. So hemorrhagic, you would see that increase in heart rate, decrease in blood pressure, the typical signs and symptoms that you think of. And then you'd see lab values corresponding to what type of fluid you're losing. For the pipes, this is your distributive types of shock where you have neurogenic with the bradycardia as the hallmark and the vasodilation. Anaphylactic, we think airway and edema, right? So you have a lot of swelling, you have a loss of intravascular fluid into the interstitial space because of edema. But we also have a threat to the airway because those leukotrienes are predominant. We have the anaphylactic response of the acquired immune system every time you're exposed to that antigen getting worse and worse. Septic shock is characteristically warm, which I didn't mention before, but that's one of the hallmarks of septic shock. But we talked a ton about the criteria of, and I mean, we have like typically a fever with septic shock, right? So chills, yeah, that could be a result. Yeah, you could see chills. With SIRS, we talked about 2 or more, so temperature less than 97 or greater than 100.9. Heart rate greater than 90 beats per minute. Respiratory rate greater than 20 breaths per minute. White blood cells greater than 12,000 or less than 4,000. Or greater than 10% bands. We could also have altered LOC or a MAP less than 65. And then in terms of the spectrum, sepsis is SIRS plus a confirmed infection anywhere. And then septic shock is a blood pressure systolic less than 90 in spite, oops, I was writing like despite and in spite, of a CVP greater than 8. So we know we have an adequate preload on the right side. That's what our CVP tells us. And then this entire spectrum can lead to multiple organ dysfunction, or MODS, where we have a failure of more than one organ system as a result of SIRS. So the different types, we could have respiratory failure, and that's your ARDS, which is your PaO2 less than 60, saying my arterial oxygen is less than 60 millimeters of mercury, despite an FiO2 greater than 60%. So that's what I was talking about with, we have an adequately oxygenated air going in, but it's not perfusing because it's that capillary membrane and the pulmonary vasculature. And we went over the different phases of ARDS. With our hematologic system failing, that would be DIC. So those criteria we talked about, where we have increase in fibrin split products, fibrin degradation products, increase in your D-dimer from those clots being broken up, but a decrease in your raw materials for clotting. We also have an increase in our bleeding times, so increase in PT, PTT, and APTT. With the other systems that could fail, what would it look like if neurologically this is being affected? Change in LOC, altered mental status. So that qualifies as another system failing. Like if they say their O2 is less than 60, PaO2 is less than 60 in spite of an FiO2 greater than 60%, and they're confused, that's neurologic and respiratory. If they say renal, what would that look like? Acute kidney injury, my GFR sucks, it's less than 60. My bun and creatinine are elevated. That's the renal system, right? So I'm looking at those lab values related to each system, and that's going to tell me which organ system's failing. GI, remember we talked about paralytic ileus? This is dangerous for any type of shock. You could result in this. Your blood is being shunted away from the GI tract, which causes hypoactive bowels, which could lead to paralytic ileus, which could lead to necrotic bowel perforation, further sepsis, complicating whatever type of shock you originally had. And this paralytic ileus could lead to bacteremia. So if you have one type of shock, let's say you have cardiogenic shock, and then you develop a paralytic ileus, that could migrate bacteria into your bowel or into your bloodstream, and you could develop septic shock on top of the cardiogenic shock. So we need to catch all these things early. Usually, the hospital, I don't know if you guys work in Bay Care, but they have SIRS and sepsis alerts where if they meet any of these criteria, any two of those criteria, you'll get a sepsis alert and you need to notify the physician in order to close that box, basically, in order for you to say that you actually dealt with it and you notified somebody, because this can progress really quickly. Metabolic system, like regulating sugar, they could develop hyperglycemia. Why might someone who's in a state of shock or trauma develop high blood sugar levels? Stress. Because the sympathetic nervous system, those hormones released, like cortisol, epi, those are counter-regulatory to insulin, meaning that they're going to cause gluconeogenesis, means new glucose in your blood, because your body wants to make sure you have enough energy to fight off whatever threat it is to your body. So you're freeing up all of this glycogen. The glycogen is that storage sugar in your liver, breaking it down. You're breaking down fats. You're trying to get as much sugar in your blood as you possibly can. But that also comes with insulin resistance, persistently high blood sugar levels, but also with stress, your tissues become a little more resistant to insulin. So then you have complications related to that. If you're in any type of shock and you convert to anaerobic metabolism, we have lactic acidosis, meaning you have a lot of lactate in your blood. Your lactate is high. We could also have liver failure. What labs do I look at for liver? Yes, very good. My liver enzymes are going to be elevated. If I have liver failure, my albumin might be low, my globulin might be low, my transferrin might be low, because all of those are plasma proteins that your liver assembles amino acids you've digested into to make them more usable in your body. So if you see any elevation in AST or ALT, that could indicate that you're progressing into liver failure, which is another system that could be affected in MODS. So like I mentioned, hypoalbuminemia, that's going to further exacerbate the fluid in the intravascular space, right? So see how all of these interact with each other. This isn't all just happening in isolation. All of these things collaborate together. We need to look at our patient holistically. Electrolyte imbalances. And those really come with a lot of the renal problems too. Our body naturally excretes, our kidneys normally excrete 80 to 90% of the potassium we take in. Our kidneys also have to match up 20 molecules of bicarb to 1 hydrogen ion. So we retain a lot of bicarb, we excrete a lot of hydrogen ions. But what happens if our kidneys fail and we're acidotic? We can't excrete as many hydrogen ions, it's further compounded, right? Because we have to match up bicarb to buffer out the hydrogen ions, keep our pH in balance. Does that make sense? So they're all interacting together. These don't just happen in isolation. Those are pretty much the big things you're going to look for with all your organ systems. And remember, MODS is 2 or more. So it's not just my O2 level and my CO2 level. It's going to be my O2 level, my mental status, my cardiac enzymes. That's another one. So cardiac, do I have elevated troponins? Is there any damage to my myocardium? Do I have poor blood pressure? Anything that works against my cardiovascular system, you look for those things and you have to match that up with another organ system to say, yeah, my patient is definitely in MODS. So if you kind of look at respiratory, hematologic, neurologic, renal, GI, metabolic, electrolyte imbalances, cardiac, those are pretty much the big ones. So this is just, you can take a picture now, I'm not going to write anything else. This is pretty much the summation of that entire chapter-ish, like the highlights. So obviously you have to read the whole thing, but hopefully that helps. Do you guys have any questions before we close out? If you filled out an evaluation, just set it at the back on those back 2 tables as you leave. And remember, this is going to be up on the Nursing Commons. It's like a YouTube link.